In order to solve this circuit using loop current method or mesh current method, we assume a loop current to each of the loops. So here, this is an arbitrary circuit. So here, let's assume a loop current here, I1, I2 in the second loop, and I3. Once we assign the loops, this is a 3. We will write the KVL equations and then we will solve for corresponding I1, I2 and I3. Now these currents are fictitious currents. They are not actual current. They are just used for solution technique. So the current in branch RA1 will be, though after the solution will be I1. Similarly in RB2 it will be I1. But for current R12 it will be actually whichever current is higher, according to that it will be this one. But while we are writing mesh current, we just assign a mesh current like that. So anyway, I will write for loop 1, I will write the KVL equation. So this is V here, then I1 R1A for the first register. For the second one, we actually assign the voltage drops in the direction of the current for each loop. So the current is clockwise, so for this one it is plus minus here, but for this one it will be plus minus here, like that. So it's according to the direction of the current. Similarly for this one again, plus minus here. So this is how we do it. Anyway, so for this one it will be I1 minus I2, since the downward currents is I1 is downwards and that one is upwards, I2. And the third one is R1B is equal to, multiplied by I1. So basically it is something like that, R1A plus R1B plus R12 and then minus I2 R12. Similarly for the second loop, there is no EMF on the left hand side, so on the right hand side I just write like that. So R2A times I2 plus R2B I2 plus R12 here, since the drop is plus here and minus over there, so I2 minus I1 plus R23 I2 minus I3. So if I rearrange it, it will be something like that, minus R12 I1 plus R2A R2B R12, the common elements, 2 3 I2, and then finally R23 I3. And for the last one, I again have run out of space, so I will just try to squeeze here. So again that's a 0. Then there is this negative current, which is minus I2 minus I3 R23 minus plus R3 R3A plus I3 R3B. So if I rearrange it, it will be minus I2 R23 and then plus of all of them, so R23 plus R3A plus R3B times I3. So basically if I rewrite them, what I can do is I will erase parts of it. So if I erase this part, so this is my V here, and then if I erase this one, this one is I0 here, and then finally this one, which is the third one. I will rewrite it here, the third one, or Yeah, so the third one is something like that. It will be 0 on the left hand side, this side, and then minus I2 R23 plus I3 R3A plus R3B plus R23, like that. Now there are three unknowns, I1, I2 and I3. We assume that the voltage is known and the resistive elements. This could be for, this is applicable for AC circuits as well. So it could be AC source here, and there can be inductance and capacitance, inductive and capacitive reactives then will come into place. But that doesn't matter, it still applies. So we assume that those things are known. So the unknowns are the currents here, because that's what we are trying to find out. Okay, so I have written the equation in specific order. This is I1 first, the three equations. I1's coefficient, I2's coefficient, and I3's coefficient is 0 here. You can say it's 0. This is I1's coefficient, I2, I3, and here again I1's coefficient is 0. So these are three simultaneous equations. In order to solve them, you can use the I can write the determinant. So 3 over 3 cross 3 determinant, and we need a little more space though. So the first row will consist of these three coefficients, the coefficients of I1. So R1A plus R1B plus R12, then negative R12, and then 0. This is the first row. The second row will be the coefficients of I2, which is R12 here. Then here this is R12 plus R2A plus R2B plus R23, and this one is R23, negative R23. So these are the coefficients of I2. Finally, the coefficients of I3, which is 0. Here it is minus R23, 2, 3, and the last one is R23 plus R3A plus R3B. So these are the coefficients. This is the denominator. The numerator will be the same, but since this is I1, the first row will be different. The first row will be the left hand side, so it will be V00, and the other two rows will be the same as the new denominator. So this is just the standard way of solving a simultaneous equation. It's nothing to do with the electrical circuit or anything. It's just a mathematical way of solving three simultaneous equations. That there are three unknowns. So anyway, I will just still write this one. It's a bit long. R2A R2B plus R23, and there are 4 terms there, and this is R23 here, and then these two will be the same as the denominator. So anyway, R23 plus R3A plus R3B. It's not readable, just R23, R3A, R3B. So that's the expression for I1, these two determinants, and for I2 it will just change. It will become, this first row will be the same, but the second row, that is the I2 row, will be the V0. So first row will be just like that. So for I2, if I do I2 here, the second row, the I2 row will be the left hand side now, and this row will be the same as before. So this will become R12 plus R1A plus R12 plus R1B, and then minus R12 and then 0. So it's the same. And similarly for I3, this row, the third row, the I3 row will be V00, and here it will be the same as this one for I3. So yeah, it's v00 because the left hand side of the equations. So by solving this determinant we can find I1, I2 and I3. So I will do an example next to illustrate this better. Thank you.